All right. What do you say we all go ahead and get started? Yes? No? We just call it a day? What do you think? Do you want a class today? Hi, everybody. How are you doing today? All right. As a reminder, I will not be in my office hours today, so I have to go off and do other stuff. If you need to talk to me, invent a time machine, go back to yesterday, okay? How's that work? But since I won't be in my office, I will just go ahead and answer questions on the project right now. Hopefully everybody started, right? Yes? How many of y'all have finished already? Come on, I know. You can admit it. They're not going to mob you and rend your flesh from your bones or anything like that. So, okay. Questions on the project? Nothing? Yes. Today. No, April 8th, Tuesday, before class. So, yeah. I'm guessing you're not done yet then. Other questions? Yeah, all right. Well, you can post them to the... Oh, you have a question. Thank you. No, I'm not going to give you the code. So the question is, how do you do the name search? Uh-huh. Okay. Okay, so the question is how to do the name search. All right, so this project has two different classes. The first class is the refugee class. And the refugee class has a method in there that is essentially, I can't remember what it's called. It's like name match or something like that. Somebody help me out there? It's name match? So essentially I can go around and let's say I wanted to find, a refugee named Bob, right? Or Scott or Michael or someone like that, right? I could go up to you and I could say, are you Bob? Are you Bob? Are you Bob? Are you Bob? We don't have a Bob in this class. Are you Scott? So that name match thing is just asking the refugee, hey, does this match your name? Does that make sense? So we can ask an individual if this matches their name or not. And that works for the refugee class. That works for any one person. Inside the program, we have the operation class. The operation is the whole refugee operation that's going on. And inside the operation class, we have a vector of refugees, right? And so in that vector of refugees is every single refugee. So what you can do is if you want to find somebody who has a particular match, you can go through the refugee vector, and for each refugee go, hey, does this match your name? And the refugee class is going to tell you first, last, exact, or not at all. So you'll get an answer back. Does that make sense? So the way to do the name search, now there's questions. Now the way to do the name search is to iterate over the vector of refugees. For each refugee in there, call the name search method on the refugee with whatever you're looking for, and then look at the return value. The return value will be an exact match, a last name, first name, or not a match at all. Does that help?
Yeah. Also, the method is supposed to return a string.
Yep.
Is that string supposed to be...
The string is one of, I can't remember exactly what I said in the project, but something like first, last, exact, or none, right? And that tells you whether the first names match, the last names only match, whether both names match, or nothing matches. So it'd be like, like if I wanted to pick on people, I could say, this is my vector of refugees, this line of people right here. And I would say, is your name Michael Lanassa? What would you tell me? None. You'd say none, no match. Is your name Michael Lanassa? Is your name Michael Lanassa? First, is your name Michael Lanassa? Yes, exact, right? So we get no, exact. Okay? Does that sort of make sense? Is that how the search works? Yes? Yeah, I want you to output the appropriate thing depending on what thing you get back. So it depends what kind of search you're doing, right? Like I can't remember what I did for the project, but you can see that depending on which string you get back, you can choose to do something with the refugee now that you know it's a match or not. Yes?
How do you do the name match for the refugee?
How in it, the method, the name match method gets the first name and last name, and you compare it to the refugee's first name and last name and see if it matches. Yeah, an if statement's going to be helpful in there, yes. I don't know what happened if your program just kept going. You'd have to ask a TA or let me see your code. So. Yes?
If the refugee is an exact match, should we output them the exact match line and the first and last name line, or just the exact match line?
All right, so the question now is like, when you actually output these things, how do you output them in a neat way, right? And the question is, if you want to put all the exact matches at the top, then all the first names and all the last names, there's a couple of ways you could do it. The way I would do it, because I'm lazy, is I would just go through the vector all the first time and go, hey, are you an exact match? And I would put all the exact matches out. And then I would go through a second time and I go, hey, are you a last name match? And then I would put and then I'd go through the vector a third time and say, hey, are you a first name match? If you wanted, you could do something clever like creating 3 vectors of like exact matches, first names, last names, and you could put a copy of the refugee into there, and then you could go and iterate all over those when you're done, and you only have to go through the list once, but it doesn't matter. Do whatever's easiest. Okay? Sir?
In the operation test int main that you gave us,
Yeah?
there's this part where you're entering in a first name and then unknown.
Yeah?
And you say you want it to return a first name match, but the data file or the data point for that individual is first name and unknown. So it comes up as an exact match.
Huh. So what you're saying then is that
Is that
if
the person says
so what you're saying,
unknown,
if you're saying, say I want to search for somebody on first name and I don't know their last name, so I enter the field for unknown. What you're saying is in the refugee name might be unknown if it's a child or someone who's unable to, and it turns up as an exact match?
yeah, and furthermore,
Well, you better figure out how to get around that because it's not actually an exact match, is it? So, I'm not going to tell everything. You got to figure some stuff out yourself. If someone's searching for, if somebody is searching on doing a first name or a last name only search, then you should not be printing out people who have an unknown as an exact match because it's not an exact match. Unknown isn't really a last name. Or a last name match for unknown. So you have to be a little bit more clever in how you do your comparisons. Yes? Uh-huh. I mean, we're trying to keep this simple, right? Like, in the real world, what we might do is, particularly if we're dealing with populations that weren't entirely literate, we might be doing some sort of phonetic thing where we enter the name phonetically, right? And then we would match different phonetic things. And there's actually algorithms that do this. Like when you enter something phonetically, it tries to match names based on how you spelled it phonetically versus how I spelled it phonetically. Maybe a little bit more complicated than we want to get into in this class. But so if there's a misspelling, just match whatever is spelled exactly. Okay?
But in the first name match, should we only be matching to unknown last names? Or
Yes, you should only be matching to unknown last names. So if you have a first name and there's a last name, and I can't remember what I put in the project. You tell me. Run mine and see what it does. That's my answer. Or send me an email or post on the discussion forum and I'll check. Because I don't remember, I wrote that like more than a day ago and I've already forgotten. So I'm sure you know how it goes. Other questions? I can't remember. I put some stuff in the comments there about how it's supposed to do, and I don't remember what I put there. So, other questions? Projector is very loud today. All right, who wants to have class outside? See ya. So if we had class outside, there'd be no projector and there'd be no recording, and you would never be able to go back and watch the video. Is it worth the trade-off? Not to me. All right. Last time we continued talking about classes. What is a class? An hour and 15 minutes that you'll never get back. What is a class? Yes? Uh-huh. Yep, a collection of data and functions on that data. And what are those functions on that data called? Methods. It's a method if it's a function that belongs to a class. We have an object. What is an object? I heard someone muttering something about instantiated. Yep, a thing, an object is something that's instantiated from a class. So the class is the blueprint. We call the class. We actually get the object. We have multiple objects of the same class if we want. Oh, I already did that one. Okay. So we had a method, and a method was something, a function that's part of a class. What is an overloaded method? So we were talking about overloading last time. What does overloaded mean? Yeah. Yep. So it's a method that has the same name. And how do we tell overloaded methods apart if they all have the same name? They have different parameters, right? They have different parameters. So an overloaded method is a method that has the same name as other method, but has different parameters. And the compiler can tell it apart because if you have one method that takes an int and one that takes 2 ints, they're different. If you take one that takes a string, that's different as well. Then we talked about operators. What is an operator? Operator, it's the guy who stays on the ship in the matrix and dials you back in. And the agents are after you. All right, I'm trying up here. All right, what's an operator? Yes, sir.
An operator is something that you can change in the program to make it do whatever you want. Kind of like it could be any sign.
Thank you. That's the word I was looking for. It's a symbol that causes some calculation to happen, right? So like the plus sign we're used to, and that's what we did last time. It's some sort of symbol that causes a calculation. So if we have methods that can be overloaded, we can also overload operators. What is an overloaded operator? Yeah. Yeah, it would be an operator that has different parameters, and it works with different classes. And the way method works is that we look at the parameters that are like inside the parentheses with the method, and we can see they're different. The way an operator works is we look at the things on either side of it, right? So we have a plus sign, you have something on the left, you have something on the right. That is the operator, and the thing it's working on is the stuff on the left and the stuff on the right. Okay? Yeah? Okay. So what's the point? The question is, what's the point of an overloaded method or an overloaded operator? And why don't we just rename it and come up with different names? So it turns out often that you have many ways of doing the same thing. Okay? And even though you have many ways of doing the same thing, it's just convenient for the programmer to go by the name of what you're doing. So if you write a method that's like cut down a tree, right? You can cut down a tree with an axe, you can cut it down with a chainsaw, or a herring, just depending on like what your particular task is. So rather than, name each thing cut down tree with axe, cut down tree with chainsaw, we just say cut down tree, and then the parameter you pass it in governs which way you do it. And it's kind of conceptually easier for the programmer that way. Same thing with the operator, right? The whole point of doing the overloaded operators is if we have some mental model that we can add things together, instead of doing .add, why not use the plus sign, right? Why not use the plus sign? And so the idea of overloading is just to make things easier on us as programmers, because we can do things conceptually without worrying about which particular one that we want. Okay. All right, so let's go back and look at what we were working on before. We were working on this point class, which represents a point on the Cartesian plane. And we had overloaded the operator for the plus sign. So before we had been, adding things and creating a new point. Now we overloaded the plus sign to do exactly the same thing. And notice the code here is exactly the same. The only thing different is how we have declared the code, right? Only thing different is how we declared the method or declared it to be an operator. All right? And both work exactly the same way. So there's not really any difference between methods and operators except how they are used in the code, whether you want to do .add something or you want to do plus for something. Okay. And what we're going to do now is, let's say we wanted to read data in from a file and we wanted to create a bunch of points. How would we do that? I've got an idea. Let's create a file of points. So here's our point.txt, and we're going to have some points in here. What's your favorite point? 5, 3. Any other people have favorite points? That's a good one. Yeah, I like that one too. Other points? 4, 7. All right, one more, otherwise this exercise will be pointless. Come on. Let's not use 0, 0. That's a boring point. Something other than 0, 0. 8, 2. Okay, so here we have some points, and we want to actually read these in from the file and create a bunch of points. So, come on. I'm not used to the trackpad on this, and I keep using 2 fingers. I don't know if you notice, and it pops up menus all the time. All right, so here's what we're going to do is we're going to get rid of all this stuff, and we are going to read in a bunch of points. And here's our algorithm. Our algorithm is going to be read points from a file and print out what they are. Pretty straightforward. Sir? You can have an int main 2. Yes, you can. You can have other functions beyond that, but anytime the program starts running, it looks for int main. So int main 2 would not be anything special. Like main is special because when the program starts running, it starts running there. Int main 2 would be like any other function name, yeah. So, all right, so how do we read things from a file? Anybody remember this? Mm-hmm. All right. Oops. We give it an input file, and we'll just go ahead and call this point.txt. So we don't have to do input. And this will try and create the file and open it all at once. Okay? Did I show you this notation before? All right, well, I won't do it this way then, because I don't want to confuse you. But you can do that. You can do it all at once. Do it that way. Okay, does this look better? You don't need a C string in this case because it's a string literal. It's inside the double quotes, so it's fine. Only if you have a string variable that you need to convert to a C string. A literal inside quotes works either way. Okay. All right, now what? What's the next line of code I'm right? What? Yes, air check. We'll air check and we'll return a little error code. All right, now we can start reading things. We can start reading things from the file. How would you want to read these things from the file? Yes? Uh-huh. While. Yep. So we've got x comma y right there. X comma y is what we have. Pardon? Uh-huh. So we need an integer. Yep, we need to take care of the comma. So we can do something like x comma y. Oops, and I forgot the closing bracket there. That looks better. All right, so here we are. We're inputting x and y, and we're going to print out things. See out x, comma, y. How's that look? Look good? Should we compile it and see? Let's just see if it works, okay? All right. All right, that works. And we're done, right? What did we do here? We just printed stuff. We didn't actually create any point objects, did we? No. So we didn't even use a class. This isn't doing what we want to do. What we really want to do is we want to create a point and then print out the point. Okay? How do we create a point using this? Yes, sir. Uh-huh. No, okay. You want to do x dot, what's x? X is an int. I don't know if an int has any methods on it. Pardon? Yes, sir. Yeah. Like that? Okay. Doesn't this need a name though? How's that? Well, we're not going to keep track of them. We're just going to print them out. So all we have to do is something like current point dot draw. I think that's what we called that method, right? So now we're reading things in. We do current point xy. We create a point and we draw it. Let's see if that works. That worked too. How's that? Is that pretty awesome? Yes? Yeah, so what happens is every time we read a point, we create a variable called current point, and we put the data in there, and then we print it out. Now, the question is, does this current point go away each time? I don't think it does. I think it just gets overwritten each loop. But we only ever have one thing called current point. We've lost the last one when we go through the loop again. Okay? We've always forgotten the last one. All right. How many of y'all think this is awesome? How many of y'all think this is perfectly bland and boring and you could have done this yourself because you've already done it for your project, something like this? Okay, it is bland and boring. How about this? How about we did something like this? How about that? Does that look nice? Okay. This is what we're going to talk about. Actually, one sec. I'm going to save this as a version of this file so that I will have a separate version uploaded. And I messed it up. I should have taken a snapshot when I had a chance. Make sure I didn't screw anything up. Okay, so I'm going to save this one as point, and I'm going to create a new one called point2.cc. All right, and now for point two, what we're going to try and do is just input things directly into the current point. How's that? Does that look cool? Why are you shaking your head? I think it would be cool to be able to do this, right? We've been able to input into X and Y. We've been able to input things. How about we input into one object all at once? Why are you shaking your head? You don't want to do it? Oh, it's not. It's not going to work. I'm not asking if it's going to work or not. Oh my God. Oh, it's because I changed the name. That freaked me out for a second. It's like, how did that? All right, that's much better. All right, so it's much better when we get like a few hundred lines of error output, right? And so if we go back and look, the first thing it says is it goes, hey, I don't know how to do angle on a current point, on whatever point class is, it just doesn't know. So you're right, it doesn't work right now, but wouldn't it be cool if it did work? How many of y'all think it'd be cool if it did work? This gets to be very cool, right? Because now you can take these big complicated files full of data and you can input them and just create one object at a time. Instead of having to like read 17 or 20 or 100 different things and then create the object, you just create the object at once. And it makes your code a lot easier to read and understand, hopefully, right? Isn't this easier? We don't even need X and Y in common anymore, they're gone. Here's what we're saying is we have a current point, we read things into the current point and then we draw it. No futzing around with sets and gets and stuff like that. Wouldn't it be awesome if we could do this? Yeah.
So if you were to change the angle operator, would that have, it would mess up like when you see and stuff?
Okay, so the question is, say we change the angle operator to work with a point. Does it mess up other things? How many of y'all think it's going to mess up other stuff? How many of you think it's not? How many of you think this is a trap? And if you raise your hand, I'll call on you. And you're still not raising your hand? Okay. So we just talked about overloaded methods, right? And overloaded functions. And then we talked about overloaded operators. When we overloaded the plus sign to work with points, did it break addition? It didn't. And the reason it doesn't is because the operator, the plus sign, looks at what's on each side. On one side, if there's a point and there's other side a point, then it does the point addition. If one side's a double and the other side's a double, it does double addition. It's overloaded. So the idea of overloading is that one symbol or one method can work with many different types. And so if we overload this angle-angle operator, it's still going to work for everything else, but it's also going to work for the point class, and we're going to be happy, right? Who's going to be happy? Only one person. All right, well, I hope the rest of you doesn't plunge you into a pit of despair or anything. So let's look at how to do this. So it's a little bit different because previously, when we talked about overloading, we actually talked about what did we talk about? We talked about overloading. Oh, working with only one class, right? When we did overloading before, we were adding like 2 point objects together, right? Now what we're working with is we're working with different things. We're actually working with an iStream, which is an input stream, and a point. So it's going to look a little bit different. So here's how it goes, and I'm going to try and do this in a way that hopefully makes it clearer as we go along. And if it doesn't work, I'll just revert to the more complex way. Okay? Are you good with that? All right. So you don't know this yet, but the iStream is the input stream, and IFStream is the input file stream. So magically, we're just going to call iStream, and we're going to say that we have an operator. And what is the operator? Angle, angle. And inside this operator, we're going to have 2 things. We're going to have an iStream, and there's an ampersand. Anybody want to guess why there's an ampersand there? Ampersand? Seen ampersand before anywhere? It's a reference parameter. So what happens is that anything that gets changed in this method gets changed back in this stream. And then we also have a point, and it is also a reference parameter. So notice I set this. This is before public and private. Let me just see. I'm not even sure this. I should probably just do the way I know instead of trying to be pedagogically correct. All right. Well, it seems to be working. Okay. So we'll just pretend it's public for right now. Okay. Everybody good with that so far? And so we're creating an operator, and this operator, instead of just working on a point, works on an iStream, which is an input stream, and a point. Everybody with me so far? Just like before, we had this point only had one parameter, because the parameter on the left was going to be a point because it was part of the point class. This one has 2 parameters. The one on the left is going to be an iStream, and the one on the right is going to be a point. Sir? Yes. Okay. So what's happening, like logically, is that data that's coming in and out of a program is considered a stream. It's like a stream of data that's coming in. And you have an iStream, which is an input stream that's data coming into the program, and an OStream, which is an output stream that's going out. And so what we're saying is that we're going to return the stream when we're done with it. Like the compiler and the computer is going to give us a stream of data. We're going to do something with it, and when we're done, we're going to pass it back and tell it what it was. So it gets an iStream back. The ampersand operator means that it's a reference to an iStream, and we're going to be using this operator. And then the iStream means we're going to be modifying the data stream as it comes in, because we're going to be taking things out of it. And the point says that we're going to be modifying the point. Okay? That's logically what it says, but I don't really want to go into too much detail of how it works. And now there's hands being raised, and I'm getting frightened. Yes? The reference parameter is because we're going to be changing them, and we want the changes to go back where they were called. We're changing the data stream by taking things out of it, because once we've read something, we want to know that we've read it, so we don't just read it over and over again. And we're changing the point because we're putting things into the point. Does that make sense? Yes? That is magic. Magic, okay? You have your choice. I can either call it magic, I can answer your question, or I can lie to you. Which would you prefer? Okay, it's magic, okay? Anybody else not happy with magic? Because I'm willing to lie to you or not tell you, whichever your preference is. Anybody prefer to be lied to? You'd rather be lied to? It's not really an ampersand, it just looks like one. Okay, all right. All right, so we've done this. Now what we're saying is we're overloading this operator. Now we actually have to go down and overload the operator. All right. So let's go down here. And what we're saying is we have an iStream and operator angle. And we take an iStream object, which we're going to call in, which is a reference parameter. And we take a point object, which is a reference, which we'll call, I don't know, what do you want to call it? P? Is that good? And here's how this works. We say iStream, and here the logic is pretty much what you would think, okay? We still need to get rid of the comma that's in there, remember, because our file has a comma, like that. We're still going to need an int x. We're still going to need an int y. And here's what we're going to do. We're going to say, let me think about this. Ah, man. Okay, here's what we're going to do. We're going to do it this way. We're going to say iStream into x, into comma, into y. And then we're going to say p.setX, set x with x, and p.set y to y. If I can type y. All right, how does that look? And when we're done, we need to return in because of magic. Okay, sir.
So you would never, you return in. Okay.
All right, everybody with me, sort of, so far? How many are willing to admit to being with me? How many are willing to admit to not being with me, sort of? All right, so this is just like, it's a little bit different because what I'm glossing over that's confusing is what this iStream ampersand stuff means, right? And it doesn't matter that much, okay? It doesn't matter. Do you have a question? Yes?
How does if you return the iStream, how does the variables continue on?
By magic. So the problem with showing you how to do this, right, is that to do this right in this class, I would have to explain to you how all this iStream stuff works. And the honest answer is that you don't care. You don't really care. You want to know because you're smart and you want to have a logical model. And the answer is that in order to tell you how all of iStream worked, I would make you cry, right? It would take like a day. Okay? And it wouldn't be, and at the end you'd be like, God, I wish you hadn't told me all that. And I don't mean to disparage your curiosity. It's awesome. It's just that it's not, if I answered it, it wouldn't really help you that much. Uh-huh. Yep. That's what we're hoping, okay? That's what we're hoping. Do you want to see if this works or not? I'm kind of curious because if it doesn't, I've made a huge mistake. And I'm trying to actually make it simpler for you. Okay, pressure's on. All right, it compiled. Oh, man. Oh, binary operator. What? All right. All right, well, screw it. I'm just going to do it the right way. I'm going to do it the easy way with less explaining, but with more binary operator. All right. All right, so I was going to try and do this a different way, but it's not going to work. Let me see if I can fix this. iStream. What? Oh, I know why. Hang on a sec. I was trying to talk and do stuff at the same time. When I declared this, I wrote iStream here. It should be in. Yeah. Thank you. So, thank you. That's all right. We'll get to friends in a second, okay? We're back to binary. Okay, yeah, we'll go back to friends right now. All right. Well, anyway. Nope. Nope. It's going to be a friend. I'll just tell you why in a second, okay? I thought there's another way to do it, and I probably should have done it that way first. But let's just see if that worked. Hey, look. That worked, right? Did that work? It worked. All right, so I have to do it using friend functions, which I didn't want to do initially, but here's the code, right? So here's what happens is is this. This is the code that does it, all right? And I'm going to talk about friend in just a second. Yes, you're all looking, you're about to turn on me, I can tell, yes. Because it's magic. Yeah.
And so has P, like when you set X and Y, that's like become the input in a way?
Yes, so what's happening is, just think of this. Remember down here we have input file, which is a type of IF stream. IF stream and iStream are related. They're like father and son or mother and daughter, whatever. There's some sort of relationship there. And so what's happening is like when the operator sees this angle, it goes, hey, what's this thing on the left of the angle? They go, well, it's an IF stream. And you know what? An IF stream is a lot like an iStream. And the thing on the right is a point, and so they must mean this operator right here. Because on the way we think of this is we have the angle operator. The first parameter is what's on the left, right? And the second parameter is what's on the right, with an angle between. Okay? Everybody with me so far on that part? I don't know. I don't want to change it to iStream. I'm afraid of what might happen. Invoke some sort of demon. Okay. Sometimes I try and teach this in a way that like I explain it, and sometimes I just teach it in a way that I say, just go and memorize it. Screw you, right? And I was trying to do something in between this time, and it's not working. So. Uh-huh. You're going to be reading things from a file. For your current project, you're reading refugees from a file, right? Now, I didn't make you read the refugees from the file using the overloaded operator because I knew we wouldn't get to it in time. However, we have one project remaining, and guess what you're going to do in the next project? You're going to be reading refugees from a file using the overloaded input operator. You're not required to do that for this one because it would suck for me to give to you something on Thursday, not explain it very well, then expect you to have code written by Tuesday. Right? I mean, that would be even crappier than the things I normally do. Yes? Yeah. So, which is why I made that other version of this program, the other version of the program. So you can do essentially what we did down here, right? Where this is essentially what you're going to do. You're working with a refugee object instead of a point, but you're going to have to declare all the things, create that, and then instead of draw, you're going to be doing pushback. Okay, does that make sense? Yes. Oh yeah, how about that? Actually, are there solutions from Project 5 from previous semesters? Interesting. Okay, I'll get right on not posting that. I'm done. Okay. So what we're doing now is we've overloaded this operator in order to read things. And I'm just going to point out something weird that we've done here. What we've done here is we've overloaded this operator to expect an integer, a comma, which is a character, and another integer, and then we're setting those things. Okay, so the question is, here we did set x and set y. Why did we do set x and set y? What are x and y inside P? Are they public or private? The data members, P, in this point, P, it has a data member named x and one named y. And we can go take a look and see what those are. Right here. They're private, right? So, can we just set P.x and P.y? How many of y'all think we cannot because it's private? How many of y'all think we can, even though it's private? How many of you have no opinion? All right. Logically, you would expect that you are absolutely right. That the reason we're using set x and set y is because we cannot do p dot x and p dot y. Do you remember we were talking about the person class before? Remember we were talking about the person class and we had a public data member named mood and we let anybody change the mood, but we didn't let anybody change the name. Do you remember that? So things that are private, if we tried to do p dot x and p dot y, this should not compile. Who's with me right now? This is sort of not within the method, okay? It's sort of not within the method because we're working with iStream, and does the only things that have a method would be like this. If it said point colon in front of it, but does it say point colon in front of it? It doesn't. Since it doesn't have this point colon, p dot x and p dot y are private. So this should not compile by the logic that we've seen so far. Everybody with me so far? How many of you understand what I'm saying is that we cannot do it because it's private? Okay? Now let's just see if I'm right or not, okay? Let's go ahead and compile this and see what happens. And it compiles, which is the opposite of everything that I've been saying. Now why does it compile? Do you see what just happened? I changed the code so we could just put things directly into x and y. Let's actually run it and see if it works. And it works. Not only does it compile, but it works. When it should not by our logic. And the logic is, because this is not part of the point class, and because this is x and y, and they are private data members, we should not be able to put things in there. Sir?
But is it because you're changing things in the stream so there isn't that level of like...
Nope. Here we are. In this point, we're changing x and y in this point directly. Yes? Okay. Nope. It doesn't have anything to do with the scope of x and y. Here's what it has to do with, right up here. You all are asking me about what this friend word meant. Here's what friends means in C++. Friends let friends see and touch their private parts. Okay? When inside a class you use this friend, that means this other class, which is actually the iStream class, is going to be able to manipulate the private parts of the point class directly. This is my favorite day of the semester when I get to say that. I was able to straight face it last year. I lost it at a time. So, okay. So in C++, friends let friends see their private parts. Okay. This does not necessarily apply outside of C++ or in a C++ classroom for that matter. Okay. All right. So what's happening is because we say friend, friend is a way. We have this class point right here. The point class is able to say, hey, my friend iStream, who's going to be doing input for me, I would like to be able to put things into my private parts directly. And so I'm going to call it friend. Okay. Now, this is a weird exception. This is the only time you're going to see that in this semester where we're worrying about friend functions is to do this input directly. It shows up other places as you continue in C++, but essentially what it means is if there is a need for some other particular class to have access to the private portion of a class, you can use the friend keyword to get that. All right. So this is essentially how you're going to do it. How you're going to do it for the next project. You're going to have to do something by overloading the input operator. All right. Now notice that the comma thing, okay? So this is specific to this example. And that is how you do overload the input operator. Okay. So, yes?
What I was asking earlier is, so you can do the same thing with output though? You can overload the output operator and just have it specifically format everything it outputs based on...
So the question was, we just did this for input and we took care of the comma. The question now is, can we do the same with output and have the comma reappear? I love questions like that. Guess what I was planning on doing next? Overloading the output operator so that we could have the comma reappear. Okay? So, Everybody, who's with me sort of so far right now? Awesome. Stand up, take a 1 minute break. I just went for like 45 minutes. It's similar, but the logic for all the searching is very similar to last thing, but where the data is different, right? Because the data used to be in all these vectors, and now it's in these one vector of these little packages. So, but the logic is about the same. Wait, are you two showing each other your code? If I look at your screen, will I see code? Okay, good. Thank you. Just checking. You would be flabbergasted at the things I've seen students do right in front of me. Don't you just even get me started. I had a student bring in a fax of code and start typing in a fax in a lab. And I was like, what are you doing? She's like, I'm just typing up my code. I was like, you faxed it to yourself? And she's like, my dad helped me. And I was like, anyway. Well, this was like 1994 or 5, somewhere around there. It was not recently. So, yeah, not everybody had their own computer, so there were computer labs. And when I was a TA, like we had the TA lab, there was literally a lab full of computers, and it was reserved for the class at particular times, and like the students would come to the lab. Like when you go to Chem Lab or something, you have the lab reserved. There was a computer lab that was reserved. So, yeah, I was a TA, and I had I think I was in the lab like 18 hours a week doing nothing but answering people's questions. So, which was awesome. Actually, I got really good at debugging. And I would watch one person make a mistake in that corner of the room, and then like people would be looking at their code, and it would like slowly propagate across the room. And I would watch, and and finally somebody would be like, I have this problem. I'd be like, yeah, you forgot the extra curly bracket at the line after that. And they would be like, they would just freak out because I hadn't been near their computer in like an hour. So I didn't, and how they're like, how do you know that? That was, it was really fun. So anyway. All right, let's get started again. We've been very excited, I can tell, to be able to do input directly. Let's do output directly. And this one's going to be really similar, okay? Friend, OStream. What? Operator, input, OStream, and comma, point. All right, we don't need a reference parameter in this one because we're not changing point. When we do output, we're not changing it. When we're doing input, we are changing it. So we don't need that. And then when we do output, it looks very similar to what it was before. OStream and operator. All right, so if we're going to do output, what we do is we do output into out. And what do we want our output to look like? Do we want a comma in there again? How many of y'all like the comma? All right, we'll put the comma back in. We say p.x, p.y. Return out. Okay, so just like we did before, we declared a function prototype that had that looked like. Let's do it this way. Oh no. So we did the function prototype that looked like this. It was very similar to iStream. It was friend. What does friend mean? Friends let friends see their private parts. And so what that means is OStream is allowed to see the private parts of point. And we have an OStream object and a point. And when we went to define this, yes, sir. Wait, let me finish this. We have the definition OStream operator. We give this OStream an out. We give point P. And what happens, we're essentially creating this thing out, this variable named out. And this gets passed to the output screen. All right, and this gets passed, and this is what's going to output. We don't need that X there. I typed that by accident. For y'all, it should be very formulaic. Like you can, since I'm not willing to teach you everything that goes into understanding about OStream, you should just remember this particular format. OStream, operator, angle, angle, OStream, and out, whatever thing you want. And then you just do output as if you were doing output normally, except into out and return out. I said that really quickly. But I'm sure you all understood it, right? I could probably talk faster. Yeah.
So is this a lot cooler than just making a function that does this?
Yeah, it's a lot cooler. It's a lot cooler. And I'll show you why. Let's just compile this and see if it works. See if I screwed anything up. Okay, so what this lets us do is now, see we had this current point.draw right there. This is where we're outputting things using that, right? When you do string and you want to output a string, do you do string.output string or string.draw or something? Have we been doing that? If you want to output an integer, do you do like x.draw? No, what you do is you do this. All right. So instead of calling the draw method, we're able to use the normal output that we've been using all along. How many of you all like using plus and cout instead of like .add and .draw, right? It's a lot easier conceptually if everything operates the same way. So now when we compile this, it compiles and we run it, it outputs what it got input in. And when it outputs, it's using the cout instead of the .draw. And in fact, if we want, we can do, put both together to see the difference. Pardon? Yeah, I mean, you'll be able to see, it does the draw and that does the cout, it does the draw, it does the cout. Sir?
How complicated would it be for the C and cout to have like parentheses, be able to deal with like parentheses around it?
Okay, so the question was, how complicated would it be if we had parentheses around the numbers? And the answer is not very, okay? I'm willing to put those in for you if you want to see how to handle it. But we have to remember that this is a very specific contrived example and that every time we do overloading outputting, we don't have to put parentheses and commas in. Are you all willing to abide by that? I will show you how to do parentheses if you promise me that on the exam you don't put parentheses in every single overloaded operator. Who's willing to abide by that? Who's going to put parentheses in every single operator, whether they want to or whether I want them to or not? So it's not very different. I mean, if we went in here and we added parentheses, all we would have to do is make sure we read them, right? When we go back here, when we read things, we have to do like, we just have to make sure we read them. So we get the first parentheses, we get X, we get Y, we get the second parentheses. And then when we output, we just have to output some parentheses, right? I think we just took care of it. So we'll compile it, see if that works. I'm going to show you that our data file format has changed because now there's parentheses in there, right? That weren't there before, but when we run it, sorry, not compile it, the parentheses are there. Sir?
If you wanted to do like all the IO in there,
Uh-huh.
would that still stay in the
Awesome question. So the question is, what if we wanted to do IO manip? Okay? So we're going to add the IO manip library, which we need, and then we'll go down to our output here, and we'll do something like how's that? So now we're using set width inside the operator, and let's compile that and see if it works. It works, and let's see what happens when we run it. Now you can see that the set width works. So yes, you can use IO manip, and when you use IO manip inside the overloaded operator, it works exactly like you would expect. Yes?
How does it know to call the O stream and output that?
Okay. Magic. Okay, so here's essentially what happens. Like here's what happens when we see this operator, right? The angle operator is the output operator. It's an operator just like a plus sign, and it looks what's on the left of the operator, and what's on the right, and what type is C out. You don't know because I've never told you, but it's essentially an O stream. We've been treating it magically. And what is current point? It's a point. So we have an operator with an O stream on the left and a point on the right. And so the compiler goes, hey, do I know how to deal with an operator that has an O stream on the left and something on the right? It goes, I probably don't. But hey, look, up here, very conveniently, they said, look, here's an O stream, and here's a point, and there's an operator that's going to be between them. So now there's an O stream on the left and a point on the right. Do we know what to do with that? Yes, we do. What we do is we create this thing called out, which is itself an O stream, right? And we assume we're like, I'm trying to think of a really good way to do this, but like, I don't have a good analogy off the top of my head, but essentially what's happening is C out is like a variable, right? And C out is the screen, and what's happening is this out is actually getting past C out, just like point P is getting current point. Does that sort of make sense? And so magically this out is C out because it's what was on the left, and so anything that the angle operator goes into here ends up going to the screen, because C out itself is actually a variable and it's getting passed in. Okay, does that sort of help? All right, today is like super esoteric day, right? Have you all had enough of input and output overloaded operators? You kind of see how it works? It's kind of formulaic. I mean, when you want to go and do this, seriously, I do this example in class, and then everybody thinks that they have to be there, and they don't. This is just because it is the specific format of the point. All right. Everybody kind of good with this? You think you can go do it yourself? What does friend mean? Yep, friends let friends see and touch their private parts. All right.
So that's just like a workaround that someone.
Yeah, it actually is a workaround. You're absolutely right. It is not. It is inelegant. It is horrible. It was added to the language. It was added. I think it was essentially. I don't know the whole history, but my understanding is that when they were developing the language, there's like a committee that gets together, and there was an argument over whether or not you should do it this way. But it was kind of a workaround for some stuff that would have been ugly otherwise. Yeah. So it's a hacky thing. All right, have we had enough of the point class? How many of y'all are tired of the point class? That's great. We're going to cover one thing, and then in the next class we'll get into the hard stuff. Okay? So. All right, so we'll get rid of point. We'll get rid of point.text. Here's what I want to do. I would like to, I'll probably do that. I would like to write a simple program. I'd like to go back to the good old days before there were classes, when we could just access all our data directly and everybody was happy. How many would be happy to do that? So let's just write a program, pound include, oops, I guess I should turn caps lock off, include IOStream. Oops, I guess it would help if I were not screwing up so badly. Do y'all want to take a 10-second break? Stand up. Stand up, stand up, step. I'll just get this going, and then there's no point in you watching me screw things up. All right, so welcome back. I have a little bit of simple code up here. What does this program do? Nothing. It's a nothing program that we're so fond of. Let's make it do something. Here's what I want to do. I am very interested, I don't know about you all, in finding out what the squares of numbers are. How do you all like, who likes the squares of numbers? Anybody? Squares? How do we compute the square of a number? Multiply it by itself. And we're going to be doing a lot of squares, and so we're going to be doing something often. What is a good idea? To make a function. That's a great idea. So let's write this function int sqr, and it takes an int. So it takes an int, and it returns an int. What's the int it's going to take? What's the int it's going to return? Yeah, it's going to return the square of what it's passed as a parameter. So let's write this, int sqr, takes an int, and we can call this, I don't know, x. And what do we return? How does this function work? Return x times x. Awesome. Now, we can do something like, int x equals 17. What's 17 squared? Anybody know? No way. I believe you, but I'm kind of frightened. Are you really good at square numbers? You're a math major and you've been holding out all semester? You get all the math questions from here on out, because I've been picking on just like the other ones I knew about. So, all right. I guess it would help if I had a semicolon there. What did you say it was? 289. Okay, how about this? All right. So, that's actually not fair. Math major, you'd have to be like an arithmetic major, right, to be really good at this stuff. We don't offer that. All right, so this is awesome. And how many of us are happy? Everybody happy? Yay. All right. Anybody have any other numbers they want squared while I'm up here? Anyone? A number that they like squared? 118. That's a boring number. Anybody have a different number? Pardon? 34. Come on, different number. Give me a good number. Okay, I'll do that one for you. What was your number? 34. Okay. Just because you seem a little frightening. All right, 1156. How about pi? Anybody like pi? Great. How about we do this then? Int z equals 3.14. What's the matter? What do you mean it's 3.14 is a float. That sucks. All right, well, let's make it a float then. Actually, let's make it a double. I'll make it a float. All right, float z. What do you mean? And I'll just compile this now. Wait a minute. Yeah, it just truncates it. That sucks. Double? I should have started with int. All right. And now we run it, and pi squared is 9. So we're happy, right? How many of y'all are happy? Good enough. All right. So something clearly went wrong here. Since we were working with a double, we actually need a double squared function. All right, that takes a double. Yeah. All right, so double SQR. Is this going to work, by the way? How is this going to work? They're both called SQR. I know, but it does it wrong, right? Like the problem was when we used a double, it was wrong. Like pi squared isn't 9. Well, let's look and see. Okay. So here I'm going to take x out. I'm going to leave y where it was. Okay. And so now in our program we say we have an x, we can square that, we have z, and what's going to happen is even though these functions have the same name, what is the compiler going to do? Yeah, it's going to do what? Exactly. It's going to find the most appropriate one. What kind of function is this? There's a name we've been talking about like for the last day and a half. Overloaded. Yeah, you can overload functions just like you can overload operators. And in this case, we overloaded the SQR function so that it works regardless of whether we have an int or a double. Okay? Does that make sense? All right, so let's compile this and see if it works now. It does. That's much better. All right, now we want anything. Anybody else have something that they want to square? Another number? This is horrible. All right. I'm not going to do that. I can. You can square ASCII values, yes. Okay. So here's the problem as you can see that if we had more types, like say we wanted to square other things like long ints or floats or shorts or unsigned ints, right? We would have to write the same function over and over and over again. See what I'm saying here? Like the squaring an int and squaring a double are the inside of the function is exactly the same, isn't it? Exactly the same. The only thing that's changing is what types they're taking. Does this light flash every so often? Oh, okay. Just want to make sure I'm not stroking out over here or something. Okay. Okay, so these functions are exactly the same, aren't they? What differs between these two functions? The type that they take and the type they return. And in fact, if we wanted to keep going, right, we could do, long and long double. I mean, all these different types over and over again, and every single one would have the same, exactly the same internals of the function, wouldn't it? Everybody see where I'm going with this? Would it be fun to sit down and type the same function over and over again for every data type you could think of? How many of y'all think that would be fun? How many of y'all think that would suck? Programmers don't like doing things that suck in general. Programmers are, and when we get lazy, we design our languages in a way that helps us be lazy. So what I'm going to show you is something called a function template, okay? All right, so the idea of a function template is if you have some sort of function or method, because it also you'll see later, not in this class, but later, if you have some sort of function or method where everything is the same except for the types, you can use what's called a template. And a template is essentially, we're designing a template for a function, in this case, that works on a particular class. And in this case, what we're saying is we're going to have a template that takes as a variable a class name. So before, all our variable names have been referring to variables. Now our variable name in this thing is essentially the name of the class that it takes. So T is going to be the name of the class, as you'll see in a sec. So it looks just like this. T square T. T square T value. And what we say is return value times value. Now, does this look kind of familiar to what you've seen before? Right? Before we had int square int x, now we have t square t value. We can make this x. Do you want this to be x so it's the same? Do y'all have a preference? How many of y'all like value? How many of you like x? Value it is? Okay, it's the same whatever variable name in here. And now we also have, double squared double. These things should look exactly alike for you, except in this one, t, the capital T is int, and in this one down here, the capital T is double. So what this tells the compiler, and what I'm going to do now is I'm going to get rid of these other functions because we no longer need them. We have created a template so that any type can be used in this SQR as long as that type has an ampersand operator that it works with. Okay. Now I will compile this and prove it to you. Compiles, we run it, we get the same answers. The functions themselves, oh wait, except I compiled the wrong program, so let me. It compiles, we run it, we get the same answers. Sir? So I didn't define a class. What I'm saying here is that this template takes a particular type of class, and this class word, this word class right there is not saying I'm defining a class. It's saying that the thing that gets replaced inside the template is this class T. And the reason it's a class there is because literally T is going to be a class. Like before it was int square int. So this whole class T gets replaced with a class like int or double or float. Does that make sense? And then then the compiler says, okay, then this is float squared float. And what it looks at, it says, oh, here's square of y. What type is y? It's an int. So it goes, I have to create this thing using the template that's int square int value, and I return value times value. Down here it says sees z, and what z is a double, so it creates this function that's double square double value. Okay, we can go on all day. Like we can do a character. Heaven help us. Anybody have a particular character they like? I like R. No particular reason why. I'm a little bit. I don't know what this is gonna. I actually don't know what's going to happen here. Well, I think what's going to happen is the program might get an out of bounds error. We might have to choose something. Yeah. Oh, sorry. My bad. Yeah. I'm just trying to think what's going to happen ahead of time, and I think something weird's going to happen. Yeah, we got a question mark. But the question mark just means that, so remember, a character is a series of code numbers that goes from like 0 to 256. So when we put R in there, R has some value like 80, give or take some. And so when it squares it, it makes 80 squared, which is like 720. I knew that. Okay, 6400. And so there's no character that's 6400, so it just goes, I have no idea what you're talking about, and prints out a question mark. Well, that's why I was thinking, I don't think any of these things are actually low enough that if we square them, it'll work. But if we look at the ASCII chart really fast, we could try and find something that would work if we squared it. Well, the number 1 actually has a different code value. We have to find something really low, like 10 squared would be 100. So if we put in, that would give us D. But we have to, the problem is that all of these low characters, you can't actually, the lowest thing we could put in would be a space. And that would be 32, and 32 squared would be 256, right? No, sorry, 16,535. I tab. Let's see if we can put a tab in there. All right, we'll try put a tab in there. Let's see if that even works. That might be a tab. Let's see what happens. Oh, yay! So the square of a tab is a Q. Excellent, excellent. Here, use a candy bar for that. Sorry. All right. So that's pretty much all I wanted to tell you about template functions. Now, if you keep taking computer science and you take 052, in the future you will be overrun by templates. This is just your gentle and brief introduction to them. However, I will expect you to be able to do simple template functions on the exam. Okay? So, have a good, whatever it is, weekend.